Quantum and Neuromorphic Computing. Whether it's automated speech recognition, self-driving cars, or medical research, the demand for computing performance is constantly growing. But opportunities to improve microchip performance are quickly reaching their limits. Where do you go from here? It has been over 50 years for the reason that engineer Gordon Moore, the later founding father of semiconductor producer Intel, anticipated that the potential of our virtual gadgets might double each year for the foreseeable future. This became as it became viable to double the quantity of transistors on a silicon microchip each year. What this intended became 2 times the computing energy within inside the equal area with only a minimum upward push in cost. In the subsequent decades, tech groups did in truth control to often double the computing energy of silicon chips, using speedy technological advancement. But will that retain? Supercomputing professional Estela Suarez explains why Moore's law will now no longer be legitimate forever, even though improvement will retain a pace. And why this is essential for advances in medicine, in traffic, and in weather predictions. Estela Suarez, technological development has been a certain steady in accordance to what's called Moore's law for the reason that 1965. But now we're listening to that the precept will attain its limits. Why is that? Physical obstacles are the issue. It is not possible to make the systems within inside the chip, just like the circuits, infinitely smaller. At a few point, we can attain the dimensions of an atom, and that, on the latest, could be the quit. Would an quit to microchip optimization then additionally suggest an quit to expanded performance? And give up to miniaturization way that properly have one fewer manner to growth overall performance at our disposal. So, properly need to use different strategies. There are different optimization strategies that deliver us better computing electricity and aren't immediately associated with the scale of the systems at the microchip. A lot of packages have a problem getting statistics from the reminiscence to the processor speedy enough, for example. They are continuously watching for statistics earlier than persevering with to process. New reminiscence technology are being evolved to deal with this. They provide extra bandwidth in order that statistics may be accessed extra quickly. This will increase computing electricity due to the fact extra operations may be done with inside the equal quantity of time. But even this method will in the long run attain its restricted a few point. That's why researchers and era corporations are continually in search of absolutely new strategies to make destiny computer systems ever extra effective. Why is in addition growth in computing electricity important? Are you able to deliver examples of packages or technology that may most effective be evolved and deployed if computing electricity maintains to growth? In the sciences, we need to apply computer systems to examine an increasing number of complicated phenomena in order that we will draw the proper conclusions. These phenomena need to be simulated with ever extra accuracy, which will increase our want for better computing electricity. Weather and weather fashions are one example. They are fed statistics from a number of specific resets and take many interrelated factors into account. From the chemistry of the ecosystem and ocean dynamics to geography and the plants in specific areas of the Earth's surface. All of those are even extra various however interrelated factors want to be simulated to appropriately expect adjustments in weather situations over time. Today, the calculations take everywhere from weeks to months of computing time, even at the maximum effective computer systems. In concrete terms, because of this better computing electricity might permit even extra correct predictions, which might in flip assist to save you climate catastrophes and to take extra focused measures to mitigate weather change. What different regions does this follow to? There are comparable conditions in different regions of studies and industry, like medicine. Today's computer systems cannot but create a simulation of a whole human brain, even though that would assist decisively enhance our expertise of neurological diseases. Drug improvement additionally calls for excessive computing electricity to decide the proper composition of lively substances extra quickly. Supercomputers also are used to perceive the brand new substances had to manufacture extra environmentally pleasant products. The improvement of language fashions additionally calls for an increasing number of effective computing overall performance. These are already used in lots of locations in our normal lives, like in mobile phones, vehicles and clever TVs. At the Forschungszentrum Jülich you're operating on quantum era, for you to provide better computing speeds for a few processes. What opportunities would possibly it open up? This technique is being pursued intensively worldwide, and now no longer simply at studies institutions. Large IT businesses like Google, who we associate with, are searching into it too. Quantum computer systems can clear up positive issues a great deal quicker than well-known computer systems due to the fact they carry out calculations in a very distinct manner. They use the residences of quantum physics that permit for greater compact information garage and plenty quicker execution of positive operations. Quantum computer systems aren't always higher than well-known virtual computer systems for each application. But they're extraordinarily green, specifically for optimization issues, including locating the minimal phi in a multidimensional perimeter array. Navigation is a realistic instance of this type of trouble. When you input a vacation spot into your GPS system, the PC for your tool calculates the pleasant direction, taking distance, pace limits, present-day site visitors conditions, and different elements into account. This is a normal optimization trouble that could run a great deal quicker on a quantum PC than on ordinary PC. Using a quantum PC to calculate a direction for one man or woman occurring excursion might be excessive. But believe a destiny wherein hundreds of thousands of vehicles in autopilot mode ought to make their maneuver alongside the roads of Germany in a coordinated way to get each passenger to their vacation spot as fast as possible. This might require large computing power, with a view to in all likelihood handiest be possible with quantum computer systems. To date, now no longer a unmarried quantum PC is in use out of doors of studies. How some distance are we from quantum era simply turning into usable? Quantum era these days is at approximately the equal degree as ordinary computer systems had been with inside the 1940s. There are prototype structures which have proven very promising results, however we're nevertheless suffering with unreliability and computational errors. For instance, the software program surroundings is likewise nevertheless in its infancy. Many of the realistic equipment we're acquainted with having for ordinary computer systems, like pretty optimized compiler software program, customized libraries and debuggers, aren't but to be had for quantum computer systems. Algorithm improvement additionally has an extended manner to go. What different methods or thoughts are there for allowing and boom in information processing in the way some distance alongside are they of their improvement? Neuromorphic computing is some other modern era. This is the idea of constructing a PC that mimics the manner the mind works. Our mind isn't very rapid at finishing mathematical operations, however way to the large networking amongst neurons, it's far extraordinarily green at getting to know and figuring out hyperlinks among diverse observations. Our mind calls for substantially much less strength than a traditional PC for responsibilities including sample popularity or language getting to know. Neuromorphic computer systems are looking to gain those sorts of abilities and observe them to information processing. What are the present-day forecasts? How rapid do professionals assume technology will expand with inside the coming years and decades? What assumptions are they basing their prognoses on? The present-day fashion is towards diversity. We anticipate that development will now no longer be pushed and conceivable the use of unmarried technical answer in isolation. This is a fashion web visible for years with inside the improvement of supercomputers, for instance. Supercomputers an increasing number of integrate distinct computing and garage technology to gain most overall performance with most efficiency. The technological improvement of the character additives may be very dynamic and absolutely new procedures are emerging. One aim of studies on this discipline is consequently to efficaciously interconnect the diverse additives. At the Jülich Supercomputing Center, we're growing a modular supercomputing structure wherein we're running on bringing collectively distinct procedures as modules in supercomputers. We also are running to mix traditional computer systems with quantum computer systems.